See here, in the previous session, we have seen one example program on Fibonacci series. So how can we print the Fibonacci series using recursion? This part we discussed in the previous session. Now, I want to talk about, well, see some more example programs on recursion. I want to print, I want to find sum of digits. So this is a program to find sum of digits using recursion. Program to find sum of digits using recursion. Program to find sum of digits using recursion. Okay, see here. I want to find sum of the digits. For example, I'm giving number as 456. So if we give number as 456, what we have to calculate now? 6 plus 5 plus 4. So 6 plus 5 plus 4 we have to calculate. Okay. So what is the result? Result is 15. If we give number as 786, okay, that should calculate 6 plus 8 plus 7. Okay. So this is a program to find sum of digits using recursion. So take the number. First, I explain the concept. Okay. Later, I explain the logic of recursion. Listen. For example, I'm taking number as 123. I'm taking number as 123. So what is the number now? Number is 123. So take the number, divide with 10. Take the number, divide with 10. You take any number, when you divide with the 10, you will get this last digit as the remainder value. Except last digit, remaining digits you get as the quotient value. You take any number. For example, I'm taking number as 456. Okay, so if you divide with the 10, you will get remainder as 6, quotient as 45. So what's the quotient? Quotient is 45. Okay, what's the remainder? Remainder is 6. You take any number. You will get last digit as the remainder. Except last digit, remaining digits you get as the quotient. For example, I'm taking number as 1, 2, 3, 4. I'm dividing with 10. Okay. So now quotient is 1, 2, 3. Remainder is 4. You take any number, when you divide with the 10, you will get last digit as the remainder. Okay, except last digit, remaining digits you get as the quotient. So here in this example, I'm taking number as 123. So divide this number with 10. 10 12 ja 120. 10 12 ja 120. What is the remainder now? Remainder is 3. So I want to get one digit here. So because we want to find sum of digits. So to get the digit, I'm dividing with the 10. So observe here, here we got one digit. Here we got one digit. Now take this quotient as the number. Take quotient as the number. Again divide with the 10. So what is the quotient now? Quotient is 12. Take quotient as the number. Again divide with the 10. So 10 1 ja 10. 10 1 ja 10. Remainder is 2. So 10 1 ja 10. Remainder is 2. We got another digit. Observe here. So first time when we are dividing 123 with 10, we got last digit. Next we are taking this quotient as the number and we are dividing with the 10. Okay, we are getting another digit here. Observe. 3 we got. Next 2 we got. Okay, next take quotient as the number, again divide with the 10. Take quotient as the number, again divide with the 10. So 10 0 0, remainder is 1. We got another digit. So we have to do this process till we get quotient as 0. So now here quotient is 0, stop. Okay, now add the digits. Add the digits. Okay, so here 3 is there, capture it. Next 2 is there, capture it. Next 1 is there, capture it. 3 plus 2 plus 1, calculate it. So result is 6. Print that one. So this is the concept. So here we are capturing last digit, next last but one digit, next another digit. Okay, add them. Okay, so this is the concept. Now what I'm doing is, I am assuming this number as n. I am assuming number as n. So as I am assuming this number is n. Just a minute. So I am assuming this number as n. So this is n, n value. Okay, so I want to define a function to find sum of digits. So sum of int n, we pass n value. So when we call like this. When we call this sum function, we call like this. Sum of 1, 2, 3. Sum of 1, 2, 3. So now 1, 2, 3 is the n value. Okay, so now what we have to do? 123 modulus 10, because we want to get remainder value. 123 modulus 10 means we will get 3. Okay, so next time take this quotient as the number. So first time we are passing 123 as the number, next time pass 12 as the number. So to pass 12 as the number, I want to pass like this, sum of 12. So how can we get this 12? To get the 12, I'm writing 123. I'm using division operator here. Division operator. Observe carefully here. Sum of 123 plus 10. So here, first time we are passing number as 123. We are dividing with 10. We want to get remainder value. So to get remainder value, we are using modulus operator here. Modulus operator. So 123 modulus 10 value is what? 3. Okay. So 123 modulus 10 value is 3. Okay. Plus. Next we want 2. So to get a 2, next pass this quotient as the number. Pass quotient as the number. So next time this 12 should become n. Next time this 12 should become n now. Okay, next time 1 should become n. Okay, so to get 12, what we are doing? 123 by 10. Division operator I'm using. If we use division operator, we will get quotient value. If we use modulus operator, we will get remainder value. Here I'm using modulus operator, 123 modulus 10 value is 3. Here I'm using division operator, this value will become 12 now. So we are calling sum of 12. So now 12 is passed. 12 is passed to the function. Okay. So now again, what we have to calculate? We have to calculate 12 modulus 10 value. So we get, so here we are calling sum of 123 by 10. 123 by 10 value is 12. Okay. Sum of 123 by 10 value is 12. So sum of 12, again we are calculating. So 12 modulus 10, we are calculating now. Plus, next time pass 1 as the number. So to pass 1 as the number, take quotient as the number. Take quotient as the number. So to get 1, divide 12 with 10. 12 by 10. Okay. Now observe 12 modulus 10 value is 2 plus sum of 12 by 10 value is 1. Sum of 1. Okay. In front of that 3 is there. In front of that 3 is there. In front of that 3 is there. So 3 plus. Okay. Now we are passing n value as 1 now. So sum of 1. Sum of 1 we are calling. So now n value is 1. Okay. Again what we are doing? 1 modulus 10 we are calculating. 1 modulus 10 plus. Okay. Next time we are passing this quotient as the number. So to get the quotient, sum of 1 by 10. Sum of 1 by 10. So now this value will become 1 modulus 10. So 1 we are dividing with 10. Remainder is what? 1. Sum of 1 by 10. 1 we are dividing with 10. Quotient is what? 0. So sum of 0. Sum of 0. In front of that 3 is there, and in front of that 2 is there. We already know sum of 0 value is 0. Sum of 0 value is what? 0. Apply it. So now the result is 3 plus 2 plus 1 plus sum of 0 value is 0. Calculate it. Result is 6. We got the answer. So here We are assuming this number as n. So here logic is, so this is the n value, this is the n value. To get remainder value, we use modulus operator, n modulus 10 plus sum of this 123 is the n value, so n by 10. Next time 12 is the number, so n modulus 10, sum of n by 10. This is the logic. Okay, next time 1 is the number, 1 modulus 10, sum of 1 by 10. So n modulus 10 plus sum of n by 10. So if n value is, 0, if n value is 0, so here we are calling sum of 0. So this 0 becomes a number. So finally we call sum of 0. So what is sum of 0 value? Sum of 0 value is 0. So if n value is 0, if n value is 0, return 0. Else otherwise, so sum of 0 value is 0. Otherwise, that should return this value, n modulus 10 plus sum of n by 10. So this value should be returned. Okay, so this is the logic for finding sum of digits. This is the logic for finding sum of digits. Okay, so it is returning integer value, so write it in type as int. Okay, once again I'm repeating, listen. We are taking the number, we are dividing with the 10. You take any number, when you divide with the 10, you will get last digit as the remainder value, except last digit, these remaining digits you get as a quotient. So if number is 123, when we divide with the 10, 3 is the remainder, 12 is the quotient. Okay, so with this we are getting one digit. After that I want to get another digit. So to get another digit, don't take the same number, take this quotient as the number. So take 12 as the number, again divide with the 10. So 10 1 jet 10, remainder is 2. We got another digit. Now take quotient as the number, again divide with the 10. So 10 0 0, remainder 1. We got another digit. Now take quotient as the number. So now number is 0. So if number is 0, that should return 0. If the number is not 0, calculate n modulus 10, number divide with the 10 and capture remainder value. So here we are capturing remainder value plus sum of pass quotient as the number. So here we are passing quotient as the number. That's it. Is the logic. So if number value is 0, return 0. If number value is not 0, okay, number modulus 10, capture the remainder, capture the last digit, and remaining digits pass as the number. Capture the last digit, pass remaining digits as the number. Again we capture another digit. Now pass remaining digits as a number. So like this we will get all digits here. When L value is 0, the return 0. Now calculate the expression, we will get the answer. So hence we can find the sum of digits. Okay, I'm copying this code. I'm opening developer C++. Observe here. But new source file. Okay, I'm pasting that function. Sorry. I want to copy this function only. Okay, so copy this function. Paste here. Okay, so I'm defining main function, int main, starting point of function, ending point of function. I call the sum function now, sum of 1 2 3. It returns sum of digits value. I want to print that sum of digits value. So cout insertion operator, sum of digits equals to insertion operator, sum of 1 2 3. After that, if you want to change the line, you can write endl. So this endl cout are defined in the namespace std. So we must write using namespace std here. And this std namespace is defined in the IO stream. So we must write hash include IO stream. Okay. So this is the program. So if we write this function after main, we must declare. If we write this function before main, we have no need to declare. Okay, that's why I'm not declaring the function here. Okay, so now here using recursion, we are finding sum of digits. Observe carefully. I'm running this program that is asking to save. I'm saving this program in our folder. Our folder is in the D drive, AWDC. No, CPP DSW, CPP DSW. Okay, here I'm storing some some digit dot CPP, some digit dot CPP. Save it. Observe. Okay, successfully compiled. No warnings, no errors. So successfully exe file created. So what is the sum of digits value? Sum of digits value is 6. Okay, we got the answer. Okay, for example, I'm giving another number. I'm giving another number. Observe, I'm giving number as 786. I'm giving number as 786. I'm saving it. I'm running again. So 786. 6 plus 8 plus 7. 6 plus 8 plus 7 value is 21. Okay, so 6 plus 8 or 14. 14 plus 7, 21. Okay, I'm running this program. Answer is 21. So finally we got the answer. Okay, so very simple here. Here we are passing number as 1, 2, 3. So 1, 2, 3 is the number now. So 1, 2, 3 is not equals to 0. So that calculates this one. So what happens here? 123 modulus 10 means that value will become 3. Quotient, we will get quotient. So we will get last digit. So next time sum of n by 10 means we will get quotient except last digit. Remaining digits we get as a quotient. So sum of 12. Now what is the n value? 12. 12 not equals to 0. Okay, so 12 not equals to 0. So condition false, that comes to the else block. So this sum of 12 value will become 12 modulus 10 captures last digit. 2 plus sum of n by 10. N value is what? 12. 12 by 10. Okay, except last digit, remaining digits, sum of 1. So in front of that 3 is there. In front of that 3 is there. So 3 plus 2 plus sum of 1. So now n value is 1. So this condition is false. That comes to the else block. Okay, so sum of 1. 1 modulus 10 value is 1. Okay, so sum plus n 1 by 10 value is 0. 1 plus 0. In front of that 3 is there and 2 is there. Sum of 0 value is 0. So now n value is 0. It returns a 0 here. Okay, so in front of that 3 is there, in front of that 2 is there, in front of that 1 is there. So in front of sum of 0, 1 is there, 2 is there and 3 is there. So sum of 0 value I'm applying as 0 because n value 0, that returns 0. I'm applying that one. So it calculates this expression. So 3 plus 2 plus 1 value is 6, that returns a 6. Similarly, it calculates sum of 786 also. So this hence we can find sum of digits. So here we are calculating sum of digits using the recursion. We are calling sum function within the sum function only. This is called recursion. Okay, now last example program on recursion. Observe. So this is a program to find recursion. Program to find recursion using program to find GCD. Program to find GCD using recursion. Program to find GCD using recursion. I want to find GCD value of two numbers. Program to find GCD of two numbers. So greatest common divisor. GCD stands for greatest common divisor. You already know it. So GCD stands for greatest common divisor. I want to find greatest common divisor of two numbers. So which one is the greatest common divisor of two numbers? I want to find that one. So for this, for example, I'm taking numbers as 12 and 15. I'm taking numbers as 12 and 15. So now what we have to do? Take greater number and divide with less number. So 12, 15 we are dividing with the 12. Okay, so 12 1 ja 12. Remainder is 3. Remainder is 3. I'm finding GCD now. Now take this divisor as the number. Take this divisor as the number. Now this one is a divisor. Take this divisor as the number, divide with this quotient value. Okay, once again I'm repeating. So here we want to find GCD of two numbers. So highest number I'm dividing with the lowest number. Okay, so I'm dividing y with the x. So 12 1 ja 12. Remainder is 3. Remainder is 3. So we got we got quotient value as 3. Now take this divisor as the number, divide with this quotient value. Sorry, divide with this remainder value. Okay, once again I'm repeating. Sorry, 15 is the number we are dividing with the 12. So 12 1 ja 12. What is the remainder value? 3. So 3 is the remainder value. Now take this divisor as the number, divide with this remainder value. Okay, so I'm taking this divisor as the number, I'm dividing with the remainder value 3. So 3 4 ja 12. 3 4 ja 12. Remainder is 0. So we have to do this process till we get remainder as 0. Now see the last divisor. Last divisor is what? 3. So now this 3 is the greatest common divisor. Now this 3 is the greatest common divisor. This is the GCD value of 12 and 15. So for the 12 and 15, what is the GCD value? GCD value is 3. Okay, I'm taking another example. I'm taking another example here. Okay, so I'm taking numbers as 12 and 20. 12 and 20. So take the number 20, divide with 12. Divide with 12. Okay, so 12 1 ja 12. Remainder is 8. Remainder is 8. Okay, so now take divisor as the number. Take divisor as the number. Divisor is what? 12. Take divisor as the number, divide with the remainder value. 8 1 ja 8. 8 1 ja 8. Now remainder is 4. Now remainder is 4. Okay, remainder is 4. Now take divisor as the number, divide with this remainder value. Okay, 4 1 ja, so 4 2 ja 8. Remainder is 0. 4 2 ja 8. So we are doing this process till we get remainder as 0. So now this 4 is the GCD value. Okay, now this 4 is the 4 is the GCD value. So GCD of 12 and 20. Okay, GCD of 12 and 20 is 4. So 4 is the common divisor, common greatest divisor, greatest common divisor of 12 and 20. So hence we can find. Okay, so for example, I'm giving number as 3. Second number is 15. Okay, so 15 I'm dividing with the 3, so directly it is divisible. So 3 is the GCD. 3 is the GCD value. Okay, so 3 5 ja 15. Directly it is divisible. Okay, so 3 is the greatest common divisor. Okay, hence we can find the GCD. Now observe carefully here. From this we have to bring the logic. I'm taking function name as GCD. We pass two values. First value I'm capturing in the x. Second value I'm capturing in the y. So first value I'm capturing in the x. Second value I'm capturing in the y. Okay, if check the condition. So here what we are doing, so assume that, so here x value is what? 12, y value is what? 15. So 15 we are dividing with the 12. 15 we are dividing with the 12. So here in this example, this one is the y value, this one is the y value, and this one is the x value. So y we are dividing with x, and we want to get this remainder value. So to get remainder value, we have to use modulus operator. So y modulus x. If this y modulus, so now if you take numbers as 3, 15, here 15 is the y, 3 is the x. So if that value is 0, okay, so see here. Now in this example, this 15 is the y value, 15 is the y value, this 3 is the x value, 3 is the x value. So we are dividing, okay, y with the x. Okay, we are getting remainder as 0. So if you get remainder as 0, this x is the GCD, right? Yes, this x is the GCD. This 3 is the GCD value. Okay, so the x is the GCD value. So right here, y modulus x equals to 0, then x is the GCD value. Y modulus x equals to 0, then that should return 0. That should return 0. Otherwise, else. This condition false means remainder is not 0. Remainder is not 0. Okay, so if remainder is not 0, in this case, observe. Okay, so make this quotient as the, sorry, make this remainder as the, so 15 we are dividing with 12. We are getting remainder as the 3. We are getting remainder as the 3. Okay, so take next time, take this 3 as the x value. Next time, take this 3 as the x value. So this 3 as the x value, and this 12 is the y value. 12 is the y value. So how we are getting this 12 here? How we are getting this 12? Okay, this one. This x we are taking as the y. How we are getting this 3? We are dividing 15 with 12. Okay, so here return. Okay, so which value we have to pass as the x value? This is 3. Okay, 3 means that is y modulus x value. So y modulus x value we are passing as the x value now. Y modulus x should become x. This previous x should become y. So the x we are passing as the y. So y modulus x means this remainder value will become x now. Okay, this divisor x will become y now. Next we are calling. So it will do this process till we get remainder as 0. So this is the code to find GCD of two numbers using recursion. That's it. Okay. Once again, I'm repeating. Observe here. Observe carefully. Here, first number is x. I want to find GCD in two numbers, 3, 15. So first number I'm assuming as x. Second number is y. So y we are dividing with the x. So if remainder is 0, in this case, remainder is 0. If remainder is 0, so this x is the GCD. So what we are doing here, y modulus x equals to 0. If this condition is true, that should return not 0, sorry, x. That should return x. X is the GCD value. Otherwise, that should return, here call the function, GCD function we are calling. Okay. Otherwise, make this remainder as the x value. Take this divisor as the y value. So divisor is what? X. So x I'm taking as y value now. Okay, this remainder I'm taking as the x value. So to get remainder, what we write? Y modulus x. So y modulus x I'm taking as x now. Remainder. This previous divisor x I'm taking as the y now. Okay, again we are dividing. If you get remainder as 0, x is the GCD. So this is the logic to find GCD using recursion. So I'm copying this code. I'm opening new file here. Observe, I'm pasting that function. Int main, call the function from the main. Okay, GCD of, I want to find GCD of two numbers, 12 and 15. 12 and 15. So see out, insertion operator. Okay, GCD of 12 and 15 is, I want to print like this. Insertion operator. Here we are calling the function. After that, I want to change the line. So to change the line, write endl. So here above of it, write hash include IO stream, and here write using namespace directive, using namespace std. Okay, I'm pressing F11 to compile and run. That is asking to save. I'm saving with the name GCD dot CPP. Observe the output. Observe, it is printing 3. So 3 is the GCD. Just now we found it. Okay. Next, GCD of 12 and 20 is 4. GCD of 12 and 20 is 4. I want to calculate that one. GCD of 12 and 20 is 4. So I'm copying. I'm giving numbers as 12 and 20. GCD of 12 and 20. 12 and 20 is 4. Okay, observe. I'm running it. Sorry. Run it. Observe the output. Okay, so what it is printing? GCD of 12 and 20 is 4. So hence we can find the GCD using recursion. Okay, so all the programs on recursion are over. In the next session, I explain theory part on recursion. What are the types of recursion? Okay, how stack can be used for the recursion. Okay, those things I explain in the next session. With that, recursion chapter will be over. I'm stopping the session here.